Hey guys, today's lesson is on section 7.5 called the properties of logarithms. There are three properties in which the first one we're going to talk about is called the product property. The product property tells us that if we have a log with an expression that we could have as represent as a multiplication problem, we could actually add the value of those two log expressions together. So if we have a times b as a log expression, we could find the value of the log of a and add it to log of b. For example, if we have log base 2 of 30, we could solve that or find its value or evaluate it. Since 5 times 6 is 30, we could break it down to the log base 2 of 5 plus the log base 2 of 6. In problems 1 and 2 below in this first section, we are going to use the product property to find the value of this log expression. Before we continue on, I just want to mention problem number 1. If we were to do this like a previous section and first convert this to exponential form, we would have 4 to the x power is 6. We then learned how to make same bases and set the exponents equal to each other. However, in this case, we can't create same bases with 4 and 6. What they give us here in our directions, this is just a second method of finding our value, is a bunch of log values that we wouldn't know off the top of our head, but we're going to use to evaluate these two problems. Since they give us log base 4 of 2, 3, and 5, and I want to use the product property for problem number 1, I'm asking myself what times what that they give us would equal 6. That would be 2 times 3. So I could rewrite this log expression of log base 4 of 2 times 3. I can then use what they gave us to evaluate, such that the product property says if you could rewrite it as the log base 4 of a multiplication problem or two values being multiplied, we can now find the value by doing log base 4 of 2 plus log base 4 of 3, in which they tell you the value of above. Log base 4 of 2 is 0.5. plus log base 4 of 3 is 0.7925. Adding these two together, we get 1.2925, and we are going to always round to the fourth decimal place if possible, because the more places you round to, the more accurate our decimal is going to become. We could double check to see if this is correct by converting back into exponential form as I did below, which would be 4 to the x power is 6. We're saying that x, or the value of the exponent that we could raise 4 to, is 1.2925. In your calculator, you could raise 4 to 1.2925, and you'll see that it's exactly, if not very, very, very close to the value of 6. Similarly, problem number 2, again, we want to use information that they gave us in the directions. I want to use the product property specifically, in which they give us also log base 4 of 3 and log base 4 of 5. I know I could rewrite this as log base 4 of 3 times 5. Using the product property, it says that we could take log base 4 of 3 and add it to log base 4 of 5, in which they tell us the values of those in the directions. Log base 4 of 3 is 0.7925, and I'm going to add it to 1.1610 to get our answer of 1.9535. Again, in order to check to see if you're correct, we could convert this to exponential form, 4 to the x power equals 15, raise 4 to the 1.9535 in our calculator, and see that the value is very, very close to 15, if not exact. The second property we're going to talk about is the quotient property. The product property says if you could have a log expression of the product of two numbers, you could add those two log expressions together separately. The quotient property says if you have a log expression of a fraction, we could subtract those values to find the exponent we could raise the base to get the value we're looking for. As you can see, they give us log base 4 of 2 and log base 4 of 3. So problem number 1 is basically already in quotient form already. We have a fraction. The quotient property says we could take log base 4 of 2 and subtract log base 4 of 3 from it. Log base 4 of 2, they tell us, is 0.5 in the directions, and log base 4 of 3 is 0.7925. Subtracting those in our calculator, we could get our answer of negative 0.2925. Our second problem, similarly, we know we're going to use the quotient property because it's already a quotient or a fraction for us. The quotient property says we could do log base 4 of 4 and subtract log base 4 of 3. Now, they don't give us what log base 4 of 4 is in the directions. However, we can convert it to exponential and figure it out on our own. Log base 4 of 4, the value of it is 4 to the what power is 4. Well, we know that x would have to be 1 to make that true. So the value of log base 4 of 4 is 1, and we'll subtract what they give us for log base 4 of 3, which is 0.7925, and get our answer of 0.2075. Our third property is called our power property. This is when we have the log of a value raised to an exponent. We could convert that. We could actually take the exponent and multiply the log expression to it. So, for example, log base 2 of 25, problem number 1. I want to use the power property here. So I am going to change 25 to a number that they give us in the directions to use, raised to an exponent. I know I could rewrite log base 2 of 25 as log base 2 of 5 squared. Since they gave us log base 2 of 5, I wanted to use 5 to the something power. The power property says we can now take the exponent that it's being raised to and multiply the value of the log expression. So this is 2 times log base 2 of 5, or 2 times, they tell us log base 2 of 5 is 2.3219. In our calculator, we can multiply that, and we get our answer 4.6438. Similarly, problem 2, we're going to use log base 3 of 7 that they give us in the directions and rewrite this as log base 3 of 7 squared, which is 49. We could take the exponent and multiply it times the log value. So it's 2 times log base 3 of 7, or in the directions, they tell us log base 3 of 7 is 1.7712. Multiplying will give us our answer 3.5424. As I mentioned again, we could check these answers to make sure we're correct by actually converting to an exponential form and raising the base to our answer. For example, problem 2, 3 to the x power is 49. We found out that that exponent should be 3.5424. In our calculator, we could raise 3 to that decimal, and we'll see that it's really, really, really close to 49, if not exactly 49. Our last part of our section here is solving equations with log properties. This is kind of using the log properties backwards, such that we could combine these two log expressions by subtraction with the quotient property. The quotient property says that if we have a quotient, the log expression of two numbers being divided, we could subtract the numerator minus the denominator of the log expression. Now we're going backwards. We could actually combine these using the quotient by saying log base 4 of 48 over n equals log base 4 of 6. And using the last lesson, which tells us that if the log expressions on both sides of the equation have the same base, we could set them equal to each other. So 48 over n must be equal to 6. We could solve by multiplying n on both sides of the equation, leaving us with 48 equals 6n, and then dividing 6 on both sides, getting our answer, or our solution for n, equal to 8. Problem number 2, the log expressions are being added. Which property has addition in it? That would be the product property. I could combine those two log expressions by using the product property backwards and showing that it's log base 3 of 2x times 7 equals log base 3 of 28. Or log base 3 of 14x equals log base 3 of 28. Since the log expressions on both sides of this equation have the same base, we could set 14x equals to 28 equal to each other. Divide 14 on both sides to get our solution of x equals 2. Lastly, problem number 3, we have an equation with logs on both sides, and the first log expression on the left is being multiplied by 3. What property are we going to use backwards where there's a value being multiplied times a log expression? That's the power property. We could bring this number back to the exponent and represent it as log base 2 of x cubed equals log base 2 of 8. Since the bases are the same, we could set x cubed equal to 8, and in order to solve, we will cube both sides, giving us our answer of x equals 2. Please let me know if you guys have any questions on the lesson, and I'll talk to you soon.